What are digital twins? The name itself provides a hint, but what I've learned, there's so much more to it. And as I've explored their capabilities and pondered their future, I've been very, very impressed, but there's a catch. I believe that they run the risk of being overlooked or underestimated, which is a real challenge. But it's a challenge that is not unique to digital twins. See, unclear definitions can create resistance, slow down acceptance, potentially stalling progress. History's full of innovations cresting this peak of inflated expectations only to struggle, spinning their wheels in the trough of disillusionment. Take electric vehicles, for example. They're back with that fresh, new tech aroma that we all find irresistible, but this isn't their first rodeo. EVs had their initial moment in the spotlight from the 1890 to the 1920 time range, and they were sold by various manufacturers, but combustion engines then took a lead as gasoline became more affordable, and now here we are, witnessing their comeback. Similar patterns can be seen with virtual reality. It always seems like it's on the cusp of a breakthrough. Believe it or not, the first head-mounted display debuted the year I was born, in 1968. Well, despite its long history, VR still feels like it's just about to revolutionize our world. And let's not forget about artificial intelligence. As fresh and new as AI feels to many this past year, it's no overnight success. Its journey traces back to the 1950s, with Alan Turing exploring the mathematical possibility of intelligent machines. Interestingly, AI is proving foundational for many other technologies, including today's research-focused digital twins. The birth of the digital twin concept is commonly ascribed to the remarkable events of the Apollo 13 mission in 1970. This is where 3 astronauts, stranded 250,000 miles from Earth, had to rely on mission control engineers using simulators to replicate their damaged spacecraft along with its current conditions, all in an effort to plot a safe return back to Earth. And it worked. It's a really good movie, spoiler alert. Which brings us back to my earlier point, stressing the need for clear definitions. Initially, I was caught up with that phrase, they used simulators. But it's important to view these simulators as progenitors or early models, groundwork that pave the way for what we understand today as digital twins. These are not static models. They are very dynamic. They're supposed to be. They have to be. They're capable of adapting to real-time data. The digital twins of today are data-rich, sophisticated systems that utilize artificial intelligence, virtual and augmented reality, the Internet of Things, plus a whole suite of advanced data modeling tools, all working together to enhance real-time output and decision-making. So digital twins may seem like ideal solutions for complex challenges, but their true value only emerges when we examine the specifics. And today's show centers on the research paper Gemini Mundi, Creating Digital Twins at City Scale, which is co-authored by today's guest, Jason Craig.
I always say I liked playing with Legos when I was a kid. I'm doing the same thing now.
Jason's background includes multiple patents in autonomous systems and energy control, as well as founding multiple startups. His expertise is crucial when leading diverse teams that are involved in the combination of artificial intelligence, machine learning, digital twins, and the metaverse. Well, he's now been a chief technology advisor at WWT for 5 years. As we dive into today's discussion, remember, new technologies often sound like things we already know, which can be very helpful until it's not. So I find it helpful to pivot from trying to pin down exactly what the technology is to figuring out what it isn't. That's where my engaging talk with Jason begins. My name is Robb Boyd. Welcome to Worldwide Technology Research Insights, powered by the Advanced Technology Center.
First of all, it's not AR and VR. Everyone links metaverse and digital twins to AR, VR. That's not a requirement. So getting away from how you immerse yourself into something, that's a state of the idea. That's not the whole idea. The other thing is it's always just a physical thing that exists. It can be, and there's many systems and solutions that allow it to be a physical thing that you're twinning, but it can also be ethereal, things that are new to the world. It doesn't replace business process and IT things that have been around for 20 years. The whole goal is to use compute, machine learning, AI that's been increasing day on day to make these things smarter and more usable by the public, by engineers, by scientists, by doctors, etc. So it's a better way to basically do a human to machine teaming that the
Okay.
industry's been looking at for the last few years.
And I think I was started getting wrapped around this need, for me anyway, to understand the difference between, because it a lot of it sounded like modeling to me, where we kind of extrapolate, well, how is something going to age, or what kind of pressures are going to be on this type of thing, but those could be more theoretical, and I think that's part of it. But there's a difference between a model and a digital twin,
There
as I
are.
understand it.
There. So modeling simulation has been around just as digital twins started in during Apollo 13 with NASA.
Yeah.
Modeling simulation has been around. It's been used. It's great. It's just like high performance computing and mainframes. Everything's been around. The difference is now I not only can combine modeling simulation, but I can combine AI, ML. I combine training environments. I can combine so many things into one solution. Now I'm not siloed like they used to be. I'd do a computational fluid dynamic model, and I'd do another like turbulence model. Now I can combine them all into one. So if I'm testing an aircraft, I can combine them all as one single massive simulation that we couldn't do years ago. And
Yeah.
so being able to combine those, then use large scale neural nets to look at how that all works together, is what's really new. But also being able to use data sources, so using IoT sensors to make these things living. Most twins in the past, you'd use it for a couple times. The cost of the environment setup was very expensive, and then you'd use it a few times, and then nobody would use it again. The
Yeah.
new way of using it is now they're living. So now I'm going to interact with it all the time. And our goal is to get them to where they're the interface to the physical world. So just like your laptop, you're interfacing with the digital world. Now I want the digital experience to interface with the physical world. And that's where they're going. So it's not just
Gotcha.
modeling a building. Now it's that you're interacting with that building through its twin.
And I think what you're saying, the word I'm picking up also is living, as you said it in there, which implies the data is real time, and it's how does it affect. You said it doesn't have to necessarily be a physical object, but let's stick to that kind of thing for a
That's the
moment. Just
easiest one, yes.
yeah, let's keep it in the easy lane if you don't mind. In your paper that kicked off this entire show, there's talk about doing this at city scale, and there's the implication of that as being is that digital twins are one thing at one level, there's something completely different at scale. What's the important distinctions to understand about doing this twinning at scale?
Yes, so there's two things in that in statement which were really good. One is at scale. So in the last 5 years or so, we heard of smart cities. Everybody wanted a smart city. It was going to
Yeah.
be the greatest new thing, and it flopped. One of the biggest reasons we deployed IoT sensors all over the place, and all it did was flood the user with more data. It didn't provide them any value. It
Yeah.
created more confusion, more costs. The cost of communication of IoT sensors was very expensive. It was another attack vector. But the biggest thing is it didn't provide any value. It didn't create new knowledge. It didn't give you better decision making. Now, with a digital twin and a large scale city scale, you can integrate all that into a very complex visualization, but very easy to ingest. So if I've got tens of thousands of sensors, but I've got a very high fidelity image of the city, I can very easily make decisions because now I'm looking at it through a picture instead of a 2D dashboard. I'm
Yeah.
looking at it in 3 and 4D, so I can push time forward, time backwards, and look at prediction. So I can make something that's very complex, very easy to ingest for people who are not mathematicians or data analytics engineers or electrical engineers or whatever. The second one is fidelity. So the higher the fidelity, the more complex the model, the more detail. And you have those conversations with your customers. Where do you want to start? And then what fidelity do you want to get to? Do you want to go from having an entire airplane where you could zoom in to the particle level? You could. I don't know why you'd want to, but that's part of the conversation is basically how detailed do you want to go? Where's the detail become too much
Yeah.
based on the value and the ROI? So these are all things we have conversations with our customer. And then the other thing with city scale is we had to prove that we could actually build city scale digital twins, that you could take a massive city and put it into the digital world because it's big. A city like Manhattan is huge. If you're going to put every building, every street light, that's where you want to go. And does the software handle that size? The compute handle that size? What is it going to take to build something that can a city afford it? Or do they do it in phases? And so that's where we're working with our customers about how you approach that whole thing.
Well, I like what you're saying there too, in terms of how you deliver that data based on what it's supposed. What are you designing the model or designing this to achieve?
Exactly.
Because it reminds me of, in the Matrix, the cheap trick to me was, from a storytelling standpoint, is you have all the digits, of course, coming down the screen, and then somehow somebody that with knowledge is able to look at that and discern how to translate that into something usable. But it sounds like in your city scale example, it became important in some of these failures to say, wait a minute, how are you presenting the data to the person? Because it's going to vary on the consumer versus, say, the operator in terms of what they need to see and how they translate it. Because knowing my kilowatt per hour burn rate or something to that effect doesn't mean anything to me. But if you put it in a graph and show it comparative to yesterday or the day before, or can identify what appliances I've turned on that are drawing more energy, perhaps, I don't know, something to that effect. So I like that notion of the interface. That was also my big hang up when we first started talking, because metaverse, I automatically think of Facebook type meta stuff with avatars. And as the way I translate what you've told me is that's really just more about the interface for a very limited set of things happening there. But the bigger picture, don't mistake that as being part of the omniverse, not the right term since it's a product, but the notion of the multiverse.
Exactly.
When it's operating together. Okay.
And we see the way we kind of describe it at Worldwide is digital twins are a holism of twins, means you could have hundreds of twins feeding a massive twin. Think of a submarine.
Yeah.
One submarine could have thousands of twins depending on the fidelity. You could be looking at one weld. You could be looking at one power plant, depending how detailed you want to go. But in reality, only a few people are using it. The engineers are using it. Maybe some officers are using it. But it's impacting a few people in a high level of impact. But it's only impacting a few, not all the sailors. The moment it becomes a metaverse for the submarine is when everyone on that submarine is using it now for their day-to-day activities. So different than gaming, where I'm flying around and making my avatar look great for Fortnite. This in an enterprise metaverse is I'm now impacting, like in a university, everyone in that university. So not only is it 3 dimensions, that's just an immersion layer. It's how the metaverse works together and how you can ingest. And I think that's the biggest thing, is how is it consumable? Because 2D internet is only consumable by a few people. 4 dimensions inside a metaverse is consumable by everybody, because we view things with vision. We see things we can touch. It's easier to consume something that we do every day. So that's where we're growing into, is taking a city and making it a consumable metaverse is what you want to get to. That's the end state. That's not the beginning state, though.
Well, even, stepping back from the consumables and just making sure we understand the modeling aspect. In the paper, you broke down 4 phases that were then, and then the example was aligned to scaling a smart city type design. When we look at those 4 phases, there first is the notion of a model design before you get to layer design. Can you explain what those are?
Yeah, so a city, the first thing is a model design. So Google Earth is a digital twin. It's a basic one.
Okay.
It used to be called Space to Face. It's a basic twin. It doesn't give you a lot. It gives you a building. If you go into the street level view, you can see homes, images of homes. So it's a basic twin. Is it a living twin? I mean, no. I mean, they update it, but it's not something that's constantly streaming data into it where you could do anything.
Well, when I think about Waze or something as it started showing traffic, it's like a low fidelity in a certain aspect of it, right?
Low fidelity, but it is a twin.
Yeah.
If you take the actual definition, it is a map. It's GIS, but it's also taking in data sources. So it's giving you something in the physical world that's happening in a digital realm. Okay. Now, in a city, the first thing you want to do is, how much of the city do I want to put in the digital space? That's your model. Do I want all the buildings? Do I want just the big buildings? Do I want this block? So starting small, maybe I want to just twin a 4-block radius so I can start and then grow out.
Because it's going to depend on how far in detail you're going to go in for that, right?
So that's part of the customer conversation. But once you have the model, then you can get in the layers of the model. Because in the real world, you have the subsurface, where all your pipes run, where all your water lines run, all your underground subways run, if you're like New York. You have the terrain. I mean, a city's not built flat. I mean, maybe somewhere in Iowa it's flat. But in most
places, it's got to be built on something too.
Yeah, it's built on terrain. So is the terrain moving? Is there tectonic plates underneath that you're worried about, like in San Francisco? So
But even
that's
floodplains, I think core of
floodplains.
army
Flood is
engineers.
a
Yeah.
big one. One of the
Yeah.
big parts of twinning and simulation is flood.
Hmm.
Flood reaction, damage, like Hurricane Sandy. What happened is now all generators have to be on higher floors because the water came in and knocked out all their backup power. So new buildings have to have higher, and you learn that through
Yeah.
simulation. But what you don't learn with just simulation is the problems of everything linked together, what we call order effect. Like the first order might be you lose your power. The second order means I lost power, but now I'm losing water because I don't have pumps to move water. The third order might be I've lost capability to secure prisons. I mean, there's lots of things that go on because I lost the secondary power. So being able to define that in a city is where you go. So then with the layers, you start with terrain, then you start with the underground. How detailed do you want your piping, your steam lines, your fiber lines, your telecommunication lines if they're underground? Then you have the surface layer, and this can be a whole nother layer. Traffic, roads, so anything that's on the ground. Do I want to
Yeah.
monitor traffic like you said with Waze, or do I want to start doing traffic prediction, traffic flow management? So how, if I've shut off a road, how can I
Oh,
reroute
yeah.
everybody?
Timing your lights. Yeah.
Yeah, or if I've got a big game at MetLife Stadium, what roads should I shut down to make them flow correctly to better manage traffic flow?
Yeah.
So now I can get into signal time and phasing of light. So now is it not just a pretty picture? I'm looking at all the signal time and phasing of each light. Can I update the signal time and phasing of the light to make them smarter through the twin? That's where the twin then interacts with the physical world in reality. Now that's
Getting
state.
into your living model, right?
That's the living model.
Okay,
So that's the
that's third
surface.
phase as you outlined
And then
it.
you've got the air surface, because you remember, like in New York, now we've got a whole thing we've never even imagined, 0 to about 700 feet. That's where drones fly.
Yeah.
So not just a drone flying. If I imagine a drone flying through the vortices of two big buildings, a 90-pound drone through a big enough wind will go right into that building.
Yeah.
So how do we control a bunch of drones, or eVTOLs, which are electric vertical takeoff and landing? So the flying taxis, like the Jetsons we're getting
Yeah.
into. How do we manage that traffic? Because now traffic flows 3 dimensions now.
Right.
It's not 2 anymore, not just cars. Now I've got 3-dimensional. And then high altitude.
So as we look at these four phases, you talk about the model itself, then you talk about the layers that are going to potentially affect the model. The model is a recreation. The idea is a digital version of something physical in this instance.
Correct.
And then as you talk about making it a living model, that's really about the interaction between these layers in terms of what's needed, what's the data flow, what's accomplished with it, and how does it affect the model, correct?
That's correct. So how each layer is working by itself. So I might be worried about if I have one building and someone cuts a fiber line up the street. Yes, I'm going to lose fiber. What else might I lose? Because I might lose communications on something I wasn't aware of. So being able to look at the order effect, first order effect, second order effect, and third order effect. Now, everything doesn't have to be integrated. You can just document, if I lose this fiber line, I at least know these 4 things are going to happen.
Yeah.
If that's documented in a digital twin, anyone can see these 4 things just happened. Most of the time, that's not documented anywhere. You don't have to integrate everything, because that could be very expensive, integrating all your access controls, all your physical security, all systems that you don't even have access to. But just knowing that happened is important.
The term you guys used that I really love was adhesion between these, and I'm sure it's very common, but what's the ability to kind of make these work together, I guess, is kind of part of what adhesion is about.
Yes, so adhesion is when the layers cross into each other. So when like in the subsurface, it affects the surface. So if I've got pipes affecting water in a building because someone cut the pipe, then there's no water in the building.
Yeah.
Or if I've got electricity, then there's no pumping capability to bring that water up to the top of the building. So being able to understand the adhesion and what the effect below and above happens is very important. And so being able to describe that makes sense. But then the other thing is, like you said, in fidelity, if I don't have to integrate everything. So if I know that my output from one data source is X, Y, and Z, I might just mark X, Y, and Z in the twin, and then it updates itself once a year or once a month, depending on how detailed I need it. It could be something very simple that takes the endpoint of a month where the source comes up with its answer, like once a month. For environmental, my carbon output for once a month is this many tons. I don't
Gotcha.
need to know how we got to that many tons.
Yeah.
That's that source. I just want to know that my tonnage for last year is this. So you can make decisions in the fidelity conversation, how many things you want to integrate, how many things you just need an answer. And it's part of the conversation we go with the customer. Because
I was going to say that sounds like a very important conversation because
yeah,
it make a huge difference in where you're investing, because you could be accelerating something that doesn't provide you any benefit or move you any closer to your goal.
Well, and this is what we've learned. A lot of people do digital twins or metaverses like to start big, and we think that's, and then we've seen this with AI and ML. They try to solve like the global problem.
Yeah.
We like to start small and grow and work with the customer the other way. Start inexpensive, prove the ROI, prove the value, and then keep building. So if I'm in a city, let's start with one block.
Yeah.
And how far do I need to go up and down? What levels? What are we outputting? And then keep expanding rings out. If the problem is you start with the entire city of New York and try to work back in, you'll never get there.
Yeah.
It's too complicated. And you're spending too much at a target that's moving.
Is there a future of modularity in this type of thing, to where the work in one area is standards based enough or open enough to where then that work doesn't have to be replicated, at least from scratch, to be working in other areas?
There is, and there's digital twin working groups. I think one of the biggest things, and it's still kind of who's going to grab onto it, but like NVIDIA, and Jensen decided, the CEO of NVIDIA decided universal scene descriptor is how that he believes, and I believe with that the market's going to describe 3 dimensions. So it gives you an XYZ axis. It was created by Pixar. Most movie theaters use USD. That's going to be the big kind of foundational protocol, like HTTP and HTML. Mostly HTML describes a web page. USD is going to describe the new web page, which is the 3-dimensional and 4-dimensional world. So by having that, you should be able to reprocess things that you're doing for other customers. And that's the whole goal, because what you don't want is what you're building to be a snowflake. Because if it's a snowflake, every time you're building, the cost will be exponential.
Yeah.
You want to repeat as much as you can. So if I'm doing buildings, theoretically, the building has the same things. It's got people, it's got mechanical, it's got electrical, and it's got plumbing.
Yeah.
And then material-wise, it's got glass, it's got steel. So anything I can repeat over and over, then I reduce costs. So my initial one should be this expensive, but as I ring out and get bigger and bigger, those costs should reduce.
Yeah, and if it's not, then there may be something wrong with the way you're
Then
going
you're
about
snowflaking.
it. Yeah. Interesting. Something to watch out for. And maybe even have, because you're talking about processes that take place over long periods of time. And if you're talking about a living model, you're almost talking about something that may have reached a certain maturity phase, but it's constantly being updated. So because that's your fourth phase, I listed as automation, kind of the final integration. Correct. Because it makes sense that obviously you build the living model, but it's not static. So you started with a static model that has the ability to take all these data sources and keep it so that the models always match. You want the virtual to match the physical in this instance, right?
Well, and we take lessons learned from IT and software architectures and AI ops. As you do new iterations and get rid of old systems as you keep growing, same idea. Once you put automation in, the goal would be I can make automated changes that are constant from the digital world back to the physical. So if you've got this back and forth capability, now again, long term, this is not happening day one, but the kind of pinnacle would be my digital twin is my ability to be the interface to my physical world and back and forth. So when something changes the physical, it updates my twin or my metaverse. But when I want to update the physical, I do it through my metaverse. I don't send someone a roll truck unless they have to physically touch it. I can do more internally, so I don't need as many people or as many complexities. When I have like a portfolio of 1,000 buildings, I should be able to do it all in the company like JLL, who's I think at 3,000 buildings. The long-term goal is they could do JLL's metaverse, where they're maintaining all 3,000 buildings in one metaverse, and they're making changes and updates and looking at their carbon capture all in one giant metaverse.
That is fascinating, because you're hitting on the benefits now, which is why do we go to this trouble? And I wonder, using some of if you can hit both of these things, you've got some awesome use cases, stuff you're actively working on, stuff you're happy to hold up that you've done in the past. But what are the benefits? Why are they going to the trouble to construct twins in that university setting, in the city, smart city, for the aerospace, whatever it may be?
Yeah, so I'll start. Sure, I'll start with the university. I mean, one of the things we've spoken to universities is they want to raise the number of people coming. Even in schools, they still want to be able to recruit the right people from all walks of life. So they want to be able to have students who can't get there right away to envision the school through their digital twin. Be able to walk through the school, even if they don't have a VR headset, be able to better walk through the school on a laptop or on a library desktop. Get that better experience, because the more experience they have with the school, the more likely they'll go to that school. So it's more of an experiential thing, and that's very important to universities, increasing their experiential capability for the students, because students now, they want not only the internet to have their 5 apps and 5 laptops and desktops running, but they want it better integrated, more be able to use VR if they have that capability, be able to learn through 3 dimensions how to interview with another. Like, I want to interview because I'm a business major with JP Morgan, but I want to feel like the JP Morgan person is actually sitting across the desk from me, not just in a VTC. So that's bringing students together, but they also want to be able to better manage their school, from a carbon footprint, from a electrical footprint, from the building ages. A lot of these buildings and schools are very old. So how do we make them more comfortable? All the stuff that was in smart cities, using IoT to make the buildings better, smarter.
What would be an example of the doing something different with a digital twin in that university setting for operations that they weren't able to do before?
Having a single location to manage everything. So most buildings are generally run in a silo. I'm running this building. So buildings that aren't 24/7, like a hospital, you have an idea of spin up and spin down. So I spin up this building and then I spin it down because nobody's in it at night. But I can't compare it to other size buildings, and I can't manage it from one location. So the building management people go around and look at each building, what's going on. They set it for the season, and then if someone changes it, that building's now changed, but nobody remembers that they changed it. And that's been a problem forever. I mean, building managers, and buildings, generally good building managers, run them at very high efficiency. We're not gaining anything new. The difference is, when I'm an operator of 3,000 buildings in a portfolio, there's no easy way to manage those in 2 dimensions. I could run reports, but if I've got reports of 100 buildings across half the country, and I've got another report of 100 buildings across this other half, how do I blend those together and look if I'm losing efficiency? You can't.
Yeah.
In 3D and 4D, you can start to look at them all together and start predicting, start looking at things that could be problems, looking at basically gamifying each building against each other. So if I have all the buildings that are 100,000 square feet and they're all using very similar air handling units, I want to look at which ones to replace that have the most impact, instead of just putting them in a line that this one's the oldest, this is the second oldest, so I'm going to place the oldest first. Well, the oldest might be running better than the second oldest, so I'm going to replace the second or the fourth oldest because it's in a different area and it's having more problems because of all its maintenance issues assigned to it. You can't just see that in 2D when you have 3,000 buildings. It just doesn't work. You can't envision that. And that's why smart cities had such a trouble. It's too much information. Even if it's all organized right, it's still too much information.
It almost sounds like we've got the ability now to move data at a speed, and we have the data and we can move it to where we need it greater than we have the ability to consume it. So there's got to be developments on the interface side, and how do we interact with this?
The biggest thing right now is consumption of data. Now we're generating data, internet's generating data, we have ChatGPT, all this is creating new data and new things. The problem is, how do you consume it? And in the enterprise, where we're focused, and my group is focused, is on the enterprise and the federal government, not gaming. Gaming, even though we take a lot from gaming and we give a lot from gaming, because why reinvent something like Epic's done, or EA Sports, Fortnite? I mean, they're doing a lot in heavy rendering, Star Wars, and how to render things in real time. Why relearn that? So we cross both industries, but for us is how to make consumable, vast consumable concepts easy to consume in the enterprise. And that's where metaverses and twins are really going to help And we're already seeing it with like universities, big engineering firms, et cetera.
Who should be raising their hand and potentially reaching out to you guys to say, hey, we'd like to understand how to solve maybe some very specific problems, or would like to just openly see if digital twins could unlock something for us?
It's pretty easy. I always say if you can drop it on your foot, you should be looking at it.
All right.
So software, I mean, IT's had workflow management and business rules and business process management. If you're talking about a process in the IT world, twins and metaverses are not going to change that.
Okay.
That world's been built, it's been used, it's still being used. But if you're dealing with something, it doesn't always have to be physical. I mean, we've talked about theoretical things you might build, or things that could be a possibility if you're trying to come up with a new concept for space flight. I don't know. But for us, it's anything you can drop on your foot you should be looking at. Now, to give an example, jet engine. We're looking at a jet engine for a helicopter. Each jet engine is the same jet engine, but they built thousands of them. Once they're built, they go out into different aircraft, and then they come back to be repaired. What's called work in process.
Okay.
And a jet engine has thousands of pieces, and they have hundreds of sub-assemblies. This is where this gets really good. To look at one jet engine and look at how the logistics supply chain are feeding that jet engine to be repaired and put back into the aircraft is very complex. It's connecting ERP, CRM, different systems that other sub companies have. Being able to look that in a view and say, look, I want to look at all that, looking at one engine that replicates all 700 engines they have in process. I can pull up and say, I want all my engines where the sub-assemblies are in this process. And then I can look at all the logistics and see which ones are going to be. So if I've got a sub-assembly, I've got the 10 parts associated to build that sub-assembly, and I see this one part is way delayed off these 4 engines, then I know these 4 engines are going to be pushed past my time to delivery. It's hard to see that again on two-dimensional graphs, because now I've got 10 systems trying to come together to show in a graph that would be hard to consume. But if I've got an engine where I show this one subassembly and these 4 engines are delayed by X date and it's showing red, it's very easy to consume.
Well, I can see now how people might start confusing workflow improvement, because it almost sounds like you described a steroided Gantt chart or something with,
You do.
Your dependencies.
If you have to go 3 or 4 layers down in a 2-dimensional dashboard, if you've lost, the complexity's gotten too high.
Yeah.
So, but if I go 2 or 3 layers down from a primary assembly, so a primary component, and it's 4 sub-assemblies, but I can visualize it and all the things that feed it, then I don't care I'm 4 layers down, because I can see how I started and how I got down.
Yeah.
And I can see all the pieces that feed that one little part, including where it is on some ship somewhere coming out of Vietnam, and how long it's going to take. But I don't have to look at 20 reports to get to that one answer. That's all fed into one view.
Kind of a 3D breadcrumb
Yeah,
type
it is.
trail.
It's like 3D breadcrumb trail.
Yeah.
Like we did
that's
with
really cool.
HTML.
Yeah, exactly. Well, and I was just thinking some of my favorite interface elements that have lasted through time. How do most people get started on this type of thing? And who would you like to see knocking on your door and asking, what they may fear is a dumb question about how to get started in something like this?
We're getting across the field. I think people are hearing it again, just kind of like the hype cycle and everything else. It's back in fashion.
Yeah.
But we want to get it past the hype cycle and actually is a long-term operational use. We actually support the whole life cycle of the project. So from development, from the creation of these worlds to the sustainability of them. If the customer wants to maintain them, training how to build, how the software is created, how it's all integrated, how you can run it and add new capabilities with new developers. So we go through that whole life cycle with them. A lot of our customers, they want to get to that one thing, one university, one bank, one where everything's integrated. We've talked about it for 20 years with portals and portlets, and everything was going to be this one kind of unified theory. That's where a metaverse can become, is where it's one.
So you don't think that's a mistake to think that way? That's
No,
not
I don't
leading you
think
down
so
a wrong
at all.
path. Okay.
No,
Gotcha.
I think it's a great idea, because if you can come to one unified theory, like we've all been trying to find that single equation, which we haven't, but if you can get a bank as one unified metaverse, everything happening in that metaverse becomes incredibly valuable because it's in one location.
You know, to assume as technology progresses and computers get faster as they inevitably do and everything else, your model may continue to evolve as well to the level of depth that could be afforded, to the level of adhesion between your layers, and all these kind of things can improve over time, but you still work from the same base.
Well, we tell customers, look, I don't need 20 million. We could start at 50,000.
Interesting.
It's a journey. We don't want to come in because it's a journey.
Yeah.
AI and ML has been a journey, and still a lot of people are trying to figure out how it's going to work in enterprise. Now we've got LLMs. They're trying to figure out how it's going to work in enterprise. And now we've got digital twins and metaverses, how it's going to work in enterprise. And these business unit heads who have to deal with all this are being flooded with a whole new world.
Yeah.
But if you can show in small iterations that are attainable and successful, then you keep growing. Just like a city grows, you have to grow your verse. You're not going to just, I need the whole verse of New York City day one. It's never going to happen. And we don't want it to.
Yeah.
We want to grow with them for the next 100 years.
But you guys have briefings as well to bring people in on to kind of, you could start someone out who doesn't even know what question to ask.
Generally, we have great conversations, then we move on to a couple-day workshop where we sit and kind of whiteboard out, ask standard questions, and see where we can get started.
These are very personal creations,
together.
Right?
They are, and we want them to own their new world.
But Jason, thank you so much for taking the time.
No, thank you. This has been wonderful.
Well, I trust this helps. I can see where you, of course, may still struggle with how and where this might best apply to you. Beyond the guidance already covered, it may be helpful to know that Worldwide Technology has currently focused their research on 5 verticals. There's energy, oil and gas, manufacturing, public sector, service providers, media, entertaining and gaming, and then healthcare, many of which, of course, you heard about in the show today. So the potential for growth and innovation in these areas is enormous. And Jason did cover a number of good resources I encourage you to check into, but as a reminder, I also encourage you to read his research paper, Gemini Monday, Creating Digital Twins at City Scale. Well, thank you so much for joining us today. I hope it sparks some ideas. You don't need to know anything to ask WWT for help. They have multiple ways, simple next steps you can take to continue your own investigation into these technologies, all without committing to a thing, at least until you're ready. I encourage you to harness all these tools and services offered, more than we can easily share, but all designed to ease your journey and accelerate your technology ambitions. My name is Robb Boyd. Thank you for watching.